This video will explain medians in triangles. A median of a triangle is a segment with endpoints being a vertex of a triangle and the midpoint of the opposite side. So the vertex would be C in this triangle CAB, and the midpoint would be D to create this median CD. So CD is one median of triangle ABC. Every triangle is going to have three medians that are concurrent. The point of concurrency of the medians of a triangle is called the centroid. It's always inside the triangle, as we can see in this figure down here. Theorem 5.7, the centroid theorem, tells us that the medians of a triangle intersect at a point called the centroid, that is 2/3 the distance from the vertex to the midpoint of the opposite side. So our distance from the vertex, so if we're looking at the median of BL, our distance from the vertex to the centroid is going to be 2/3 of the total distance from the vertex to the midpoint here. Now all polygons have a balance point or centroid. The centroid is also the balancing point or center of gravity for a triangular region. This means that the region is stable under the influence of gravity. So under the centroid is our center of gravity. Let's take a look at an example. In triangle ABC, Q is the centroid and BE equals 9. Find BQ and QE. So let's take a look. So we know that BE, this whole thing, is equal to 9. We need to solve for BQ. So let's solve for BQ first. We know BQ is equal to 2/3 of the whole segment BE. So BQ then equals 2/3, and we can plug in our 9 for BE. 9 equals 6. And then since BQ is 2/3, there's just going to be 1/3 left for QE. QE is going to be 1/3. QE equals 1/3 of BE, and we can plug in 9 again for BE. So 1/3 times 9 gives us 3. So we have this is going to be 3, and this is 6. Let's look at one more example. In triangle JKL, PT equals 2. Find KP. So if PT equals 2, so PT is our distance from the midpoint here to the centroid. And we know the KP, this part, is going to equal 2/3 of the entire median, so all of KT. And this part here is equal to 1/3. So if PT equals 1/3 of KT, then if KP equals 2/3 KT, we can see here 1/3 going to 2/3, we just multiply by 2. So if the smaller part is 2, we can multiply that by 2 to get the larger part from the vertex to the centroid. So KP is equal to 4. KP equals 4. And I'll show you one other way that you can solve this problem. You could say that we know that Kp is equal to 2/3 of Kt. Then we could plug in Kt we know is equal to, if we look at what comprises Kt, it's Kp plus Pt, so both of those. So let's say Kp equals 2/3 Kp plus Pt. And then we know Pt is 2, because they told us that Pt is 2. So Kp equals 2/3 Kt plus 2. And I meant to write t here. So let's simplify this. This becomes Kp equals 2/3 Kt plus 4/3. So then we can say that this is Kp, sorry. And then we minus 2/3 Kp to get Kp just on one side, minus 2/3 Kp. We get Kp minus 2/3 Kp is 1/3 Kp equals 4/3. And then we can multiply this by 3, because if we multiply this side by 3, gets rid of that part in front. So we have 3 times 4 gives us 12 over 3. Kp equals 12 over 3, which equals 4. So we can see we got the same exact answer, Kp equals 4, as we did up here. So the easiest way to remember this is that the distance from the vertex to the centroid is going to be twice the distance from the midpoint to the centroid.